The fourth industrial revolution will impact our lives completely. It will not only change how we communicate, how we produce, how we consume, it will change actually us, our own identity, and of course gives life to such policies and developments like smart traffic, smart government, smart cities. What we will see is that everything will be integrated into an ecosystem driven by big data and driven particularly by close cooperation also of governments with business, civil society. And this revolution will come at a breathtaking speed. It will be like a tsunami. And actually, it's not just a digital revolution, it's digital, of course physical with nanotechnology, but it's also biological. And so three dimension provides a particular force to this revolution. So what the World Economic Forum is doing is to promote this public-private cooperation to master the fourth industrial revolution. The fourth industrial revolution will have multifold impacts. Of course, every industry will be digitalized, will be disintermediated, and has to define a new business model. But it's not only business which is affected, it's government which has to move over to agile government, it is society as a whole, with the danger of job losses, but also with the need to reskill and upskill people fast. So there's an impact on society. So we will have to prepare very well for this revolution, and I feel that the Asian countries with a relatively young population can manage and master this revolution easier compared to other countries in the world. What is particularly important is the educational system. We have to change the educational system, which is still very much anchored. Even in the 19th century, we have to adapt it to the need to change continuously, for example, jobs. So the new educational system has not only been aiming at developing digital capabilities, and I should add ethical norms, but it also has to be based on a lifelong educational system.
We're going to start the When Humans Become Cyborg session. You know, I always want to be a cyborg. I'm waiting for the day to become one, but let's see. Like today, we like to really talk about the recent developments of brain-computer interface and how that's really blurring the line between man and machine. And that's also opening up many, many questions about social, cultural, and ethical implications of these technologies. And today we have such a perfect, wonderful panel to talk about that issue. And firstly, I'd like to introduce myself. I'm the moderator. I'm Hiromi Ozaki. I'm an artist, also young global leader from Japan, and I make artworks based on tech and future tech. And to the very, very end, it's Ronaldo Lemos, Director of Institute of Technology and Society. And Ronaldo is a specialist in law and technology in Brazil. And it's Elena Singha, Professor of Neuroscience and Society in University of Oxford. And next to me is Victor Zhao, President of National Academy of Medicine, sorry, yes.
And old global.
Hello. I am Azad and today I will be telling you about the wireless body area network and how it applies to the Internet of Things. First of all, let me give a brief definition of the wireless body area network. Wireless body area network is a short-range wireless network of wearable computing devices. Wireless body area network devices may be embedded inside the body as implants, may be surface-mounted on the body in a fixed position, or may be accompanied devices that humans can carry in different positions, such as in closed pockets, by hand, or in various bags. If we talk in the context of the Internet of Things, these implanted sensors and wearable devices are the things from the Internet of Things, whereas wireless body area network is the glue folding these implanted sensors and wearable devices together. The wireless body area networks can be described as an extension of wide area networks to personal space. The wireless body area networks can be further categorized as 1. In-body communications, that occur between two or more devices inside a human body. This communication is mostly between implanted medical sensors. 2. On-body communications, are happening within the networks and wearable systems in direct proximity of the human body. That means both wearables are located directly on or very near the human body. 3. Body-to-body communications, appear between antennas placed on two or more separated human bodies. 4. Off-body communications, are made between the devices placed on a human body and devices placed on a remote access point. Now I will tell you about some common everyday examples of wireless body area network communication we can see around us. Due to advancements in microelectromechanical systems and wireless communication technology, wireless body area network is heading toward a great technical boom. Nowadays, it is becoming more and more common to see people using wearables like smartwatches, fitness bands, and wireless earphones that are connected to smartphones via Bluetooth. The applications of bands are numerous, ranging from healthcare and telemedicine up to fitness and sports training, interactive gaming, and personal information sharing and authentication. One simple application of wireless body area network communication can be seen when someone uses their smartphones or smartwatches for contactless payment at shops and restaurants. Another example of a wireless body area network is in medical care. It is being used for continuous monitoring of vital parameters like heart rate, ECG, blood pressure, etc. of patients in hospitals, enabling better medical care. It is also being used to provide better care for the elderly in retirement homes. Another application of wireless body area network is in sports, where fitness monitoring devices like chest strap and wristbands are worn to keep track of speed, distance, calories burned, elevation, altitude and heart rate. Now I will tell you a little bit about the technologies used in wireless body area network. The most common technologies are Wi-Fi, Zigbee, Bluetooth, IEEE 802.15.6. Among these technologies, Bluetooth is the technology people are most familiar with. It is often used in connecting wearable devices with smartphones. And among these technologies, the latest technology for wireless body area network is the IEEE 802.15.6. It aims to provide short-range, wireless communications in the vicinity of, or inside, a human body. TT uses existing industrial scientific medical bands as well as frequency bands approved by medical regulators, which makes it most suitable for medical sensors. That's it for today, thank you for watching.